So I was muted. So that doesn't work very good. So we're going to try again. Here, we're just going to start right from the beginning. Do not save. It was nice enough to get a text or a PM 72 Pony about it. All right, we're going to try this again. So let's do the cube in sheet metal. A simple cube, but we're going to build it out of 3 parts. There's 6 panels that make up a cube. So we're going to do it in 3 parts. One part that consists of 3 of those panels, another part that consists of 2 of those panels, and one part which consists of 1 of those panels. And what we want to do is we're going to build a 6-inch by 6-inch by 6-inch cube out of sheet metal, have it bend up and still be 6 by 6 by 6 with no interference, and have all the flat patterns laid out on one piece. I went to a cube like this mainly because I think it teaches the fundamentals of what makes the sheet metal stuff work without getting too long-winded into canvases and different stuff that we were getting into with the other bumper. All right, so I guess we'll try to do good practice. We always start by saving our file, and we're going to call this example forum cube. Still can't get used to this keyboard, the really high-rise mechanical keyboard or keys. I like it. I like the feel of it, but I still kind of misclick often. I was never much of a typist anyhow. Okay, new sketch. It doesn't really matter which plane it's on at this stage. And you could do it, a perfect one in the center and do that good practice, but that doesn't matter either. So let's create a cube. And this cube is going to be 6 inches by 6 inches. I'm not going to give a ton of tips and tricks along the way. Just I want to keep focused on the sheet metal stuff because it's enough by itself. So let's extrude this 6 inches tall. Okay, now we have a cube that's dimensionally 6 inches by 6 inches by 6 inches. We're going to make it out of 1/4-inch plate. So that means that we need this cube essentially smaller than 6 inches to start with. So what I'm going to do is I'm going to hit S for search, O for the offset tool, pick the offset tool, and I'm going to offset everything, all 6 faces by negative material thickness or 1/4-inch. Now it's not going to look like much happened, but if I come over here into the browser bar and I toggle the visibility of this body off, you can see there's a cube within inside a cube now. Let me try to toggle it on and off now. It's like a cube inside a cube. So we're going to start worrying about this second cube. And this body could really be as complicated as you wanted, this first body. We're going to go into surfaces, because right now we have a solid body, and really what we want is surfaces, faces. So we are going to unstitch this. And it breaks it up, it hollows it right out, it breaks it up, it gives it no depth anymore. So instead of being a 3-dimensional cube, it's now 6 2-dimensional squares. And here I can prove that by just I could grab one of these by turning that to bodies. And see, it's a box now instead of a solid, and each one of these are individual. So that's great. That's what we want. And now we're going to stitch some back together. So we want 3 panels to be part of the one component, 3 with 2 bends. You can see where the bends are. They're highlighted in, or what will be the bends. But these are what's going to end up being stitched together. We're using the stitch tool right now. I'm going to make sure it's set to new component over here. I got that function. I got to be able to use that more for zooming into places, not zoom in, but highlighting. I'm going to hit OK. Now I'm going to do the same thing again. I'm going to stitch together just 2 of them. OK. And then we just have a single left, which is what we wanted. And we'll take that single panel and make it into a component. Nope, just the one panel, please. From bodies. It's hard to see over here, but sometimes you have to make sure you click the from bodies or it'll automatically want to pick other things. So there we go. And now it's created these 3 components on this side. After I stitched those together, I created a new component, and then I switched that last body to a component. And this is the important part, is each one of these that are going to be future sheet metal pieces need to be their own components underneath this assembly. You can see how this assembly, when I open and close this folder, it's jogged over one, and those are the because they're inside. So if you jog over one, you can see the same arrow for closing that, or closing that below it. Because those things are inside those things that are inside those things that are inside those things. So in this case, what we need is 3 different components. They can't have pieces inside each other, because you can't have 2 flat patterns in one component. So we need 3 components so we can make 3 flat patterns. All right. Another thing we need to know is how much radius to put on these pieces before we turn them into sheet metal. So a good way to figure that out is by using the sheet metal tool to see what it does, and then kind of backwards reverse engineer the radiuses from that information. So let's start a new drawing in whatever plane, and actually I'm going to offset a plane. I don't want it buried under there so I can't see it. Offset plane right here. There we go. Perfect. I'm going to create a sketch here, and we're going to create just a little piece angle, which is going to help us determine our bend. 2 inches. Perfect. By 2 inches. Finish sketch, sheet metal, flange, and I already have it set to my aluminum. You would have to have your sheet metal set up to however you wanted your sheet metal rules set up, so it's an important part to have that set up ahead of time. Well, kind of semi-important, mostly important, so you don't have to backtrack a bunch. Okay, I'm going to start a new sketch. I'm going to project all this, okay. And now what this is going to let me know is how much radius it is. So it's exactly 1/2 inch on the inside and exactly 1 inch on the outside. Perfect. So now when I go into here, under solids, radius, I'll radius the bend lines. Exactly 1/2 inch. That's great. Now we'll start at the first component, and this is another important point. Again, I know I was stressing it, but what's the active component? We were working in this area. We weren't working inside any of these components. We were working in all these files, basically from the start of the assembly to the first component. That's where all that radiuses and all that was happening, or at least it's so hard to explain, sorry. Anyhow, we're going to work on the first piece of sheet metal, and to do that we want it to be active. Good. So now that is active. I can only deal with that piece, and everything else is there but kind of ghosted. So we're going to go in to surface. I'm going to zoom out. I'm going to find the thicken command. I'm going to thicken this to 1/4 inch. That's great. And now when it did thicken it, it actually created a whole new body, which I'm going to turn that new body into sheet metal. And I'm going to create a flat pattern. It's going to show me what that flat pattern looks like. And of course it won't make it in the same color that the other part's in, because why would you want to do that? And technically it's a separate, anyhow. Okay, now we'll go to number 2. We'll open up that body. I will go to surface again, go to thicken. I will thicken that. And then we'll also change that into a sheet metal. Perfect. Nope. Now I'll create another flat pattern. Alright, now we have 2 flat patterns and 1 component, which just consists of a single. So we'll now thicken that last piece. I will activate it and thicken this last tile. You could use the extrude command. You could use, I'm just so the workflow is all the same, is why I'm going to use thicken. Okay. Good. Now we have this 1 normal body, 2 sheet metal bodies, and then these surfaces that we made them out of, which we don't require anymore, and they're actually invisible right now, so it doesn't matter. So now we want these all in the same sheet because we are going to cut them out. And I'm going to try not to use the arrange command because free users don't have it. Arrange is awesome. It's almost worth it by itself for Fusion. But I am super biased with Fusion. I used to be a die-hard SketchUp user, so I think that's probably why. There's a lot of similar feels between those 2 pieces of software. Okay, we're going to go back into Solid. I'm going to go to Derive. And it requires me to have this file fully up to saved before I can derive. So yes, I will save it. So now it's saved right up to this point. And now it's brought on the derive menu. I need to totally get a very small screen for doing these these live streams. I'm going to find a small monitor for doing this. So what I'm going to do is select those, the flat pattern I want, the body I want, the other flat pattern I want, and I'm going to hit OK. And what it's going to do is create another file. It's going to create another file usually with the flat patterns, it always puts them flat on the on that axis. But anyhow, that's fine. We'll move those out like that. Okay. And I also move the body. Do it this way. There we go. So there's our 3 bits that make up that cube. And actually, let's go back to the body here, or the assembly. And I want to show you that it is exactly 6 inches. So if I go from here and measure this face to this face, it's exactly 6 inches. It's hard to see in there. Try to zoom in, but exactly 6 inches because of the way we did it. So if I measure anywhere on that cube, it is exactly still 6 inches. Even though it's 3 different panels built 3 different ways, it is exactly 6 inches. And what also is nice is this is all here right now. What we can do, let's say we wanted to make this like dice, like how dice are. I'm going to open up our original cube just as kind of a little bit easier to look at for me. I want to close this too. Hide. And hide. Okay, thank you. So I'm going to create a sketch here. And I know there's a certain way dice are laid out, but we're not going to get into that right now. I easily could. So let's project that. I'm going to lay it out, just put some holes in it, just like a dice would have. Doesn't want to give me both those, eh? At the same time. That's irritating. Go X to create a dotted line. Go right through. Well, let's lay out just the one hole first. We'll do 5 on the other side. I'll punch it right through. That'll make it easier for me. Go back to a solid line. Let's say we'll do those holes, what, 1 inch? Be the right size, I guess. All right. Okay, that's cutting through everything. Four by 4. I keep worrying about going too slow, but it's the main complaint I get about is going too fast, so. It might be a little big for spacing. That was going to be at the 5-inch one, so let's go a little tighter. Let's go 3.5. Alright, let's make some more holes. One inch. Okay, let's extrude those holes. What do we need now? 2, a 6, all the other ones. Let's do another sketch on top. I'm going to project this whole face. I think 6, I might have to go a little bit wider. No, I can't go 6, I'll have to go 3.5. Okay. One inch. This is going to be our 6th side. We really already have covered the kind of the meat and potatoes of the did I offset that? That's not in the center, is it? Of the sheet metal part of the talk today, but look at that. How did I do that? Just all over the place. Alright, that's a little better. We'll extrude this now. Okay. I don't know. Is a 1 on the other side of 6 usually? I'm sure there's some dice aficionado out there that knows. I could look at a dice, I guess. There we go. 1 inch. Extrude. Oh, I already did 1. That's not going to do me any good. 2 then. Holy, is 2 diagonal? 3 is the one that's diagonal from each other, right? Yeah, that's about right for the 2. This is a little duller than I thought it was going to be, but that's okay. It's going to get the point done. Get those a little closer together. They won't fall far apart. That's better. What do we need now? 4 and we're good? No, 4 and something else. Sorry, a little dull, this one. X. Draw some circles. Nope. Right. And a 3. Almost too far apart, eh? For the, I think I made the 5 too far apart. Well, let's not get too crazy here. Well, we're probably already beyond that, but yeah, it made it way easier to go back to the original cube, though, to overlay it for some of these cutouts. And I'm slowly dragging from the edge because it'll automatically kind of hone to where I want it. It's not going to do it on this one, though, of course, but sometimes it does. 95% of the time, 100% of the time if I'm not on the live stream. Okay, this is going to be the 3er. And the last few holes. And we'll extrude them. And then finally we can get to the magic. Alright, so now what's happened, if we save this, you can see that it's put the holes through for us, and they're in the correct places. But what it's also done is if I go into here, you can see the alert, but if I go and regenerate this derived, they see how it just automatically updated all that. So that's super convenient. Anyhow, there's another crash course on this. I think I should sit down and actually write kind of a script up and do a video up for my YouTube channel. It's a little more comprehensive on this, but it's so easy to get out in the weeds on this particular topics. All right, thanks guys. Take care.